next class. This class is for class 9 in continuation to the previous class of exponents, in which we were discussing exercise 8 and we have done up to question number 17 second part. Now I am continuing the same exercise with question number 18 second part, and the question reads x to the power a upon b upon x to the power c whole power a minus b into x to the power b plus c upon x to the power a whole power b minus c into x to the power c plus a upon x to the power b whole power c upon c minus a. Now what you can do in this? First of all, we know that when the power is in denominator, if we bring it to the numerator, its sign gets changed. So it is x to the power c. If I bring it to the top, it will be x to the power minus c. I am writing it here. X to the power a plus b upon x to the power c can be written as x to the power a plus b into x to the power minus c. We can write like this. Now we know when the bases are equal, powers are added. So finally this can be written as x to the power a plus b minus c. It means in place of this whole expression, we can write a plus b minus c, a plus b minus c. So this way I will be writing all the three. So first, in place of this, I can write x to the power a plus b minus c, and whole power is a minus b into, similarly, x to the power b plus c minus a whole power b minus c into x to the power c plus a minus b whole power c minus a. I hope this is understood by everyone. Now we know when there is a power of power, let's say x to the power m whole power n, it means x to the power mn, or we know that powers of powers are multiplied. So this law we will be using in this. Now this can be written as x to the power a plus b minus c into a minus b into x to the power b plus c minus a to the power b minus c into x to the power c plus a minus b into c minus a. Now what we can do, powers can be multiplied, and you can see that all the powers, different powers, are having the same base x, and in between there is a multiplication sign. When the bases are same, let's say x to the power a into x to the power b means x to the power a plus b. So first of all, we'll be using this formula. Bases are same, powers are different, so we can add up all the powers. So this can be written as x to the power a plus b minus c into a minus b plus, let's put a bracket like this, plus b plus c minus a into b minus c, and plus c plus a minus b into c minus a. What we have done? We have used this identity. You can see that the bases are equal and the powers are different. So whenever bases are equal and with different powers, the base remains same and all the powers are added. So we just multiplied, let us say m, n, o. So this is m, n and o. Now you multiply these, so it can be written as x to the power a into a is a square minus ab plus ab minus b square minus ac and plus bc. This expression is for the first one. Then plus. In this, it will become b square minus bc plus BC, B into C, and minus C square minus AB and plus AC. This total is coming by these two. Then third one, so again plus, now C into C is C square, C into minus A is minus AC, plus A into plus C is plus AC, plus A into minus A is minus A square, minus B into C is minus BC, and minus B into A is plus AB. Now minus AB plus AB cancelled, minus BC plus BC cancelled, minus AC plus AC cancelled. Now what is left now? X to the power A square minus B square minus AC plus BC plus B square, this is the B square, minus C square minus AB plus AC plus C square minus A square minus BC plus AB. Now whatever is left says in between there is a plus sign, so we add all what is left. Now plus A square minus A square cancelled, minus B square plus B square cancelled, minus AC plus AC cancelled, plus BC minus BC cancelled, minus C square plus C square cancelled, minus AB plus AB cancelled. It means nothing is left in the zero. What is left? Nothing is left in the powers. What is left? X to the power 0, and we know that anything which has a power 0 is equal to 1, so that is the final answer. Now we move on to question number 19. Now question number 19, first part, it is L mth root of x to the power L upon x to the power m into m nth root of x to the power m upon x to the power n minus n lth root of x to the power n upon x to the power L. Now how to solve? Suppose it is written 5 and 4th root. It means it can be written as 5 to the power 1 upon 4. For example, it is written square root of 9. The square root of 9 means 9 to the power 1 upon 2, which can be written as 3 square. 9 is 3 square to the power 1 upon 2. This 2 and this 2 will cancel. Final value will be 3. So it is 4th root. 5 can be written as 5 to the power 1 upon 4. Or you can say cube root of 27 can be written as 3 to the power 1 upon 3. Similarly, I am writing the first part. It is written L mth root of x to the power L upon x to the power n. First of all, what are we going to do? We will convert the power that are in denominators to negative and bring them to the numerator. So this question can be written as L mth power of x to the power L minus m. My m goes to the numerator. Since here it is positive, when it will go to the numerator it will become negative, or I will write it over here. X to the power L upon x to the power m can be written as x to the power L into x to the power minus m. We know when the bases are same, powers get added. So x to the power L minus m. When you add plus minus, or if you want, this can again be understood as L plus minus m. So finally it becomes L minus m. So that is why it is L minus m. Now this we got into m nth power of x to the power m minus n into n lth power of x to the power n minus n. Now we know that in this case 4th root of 5 means 5 to the power 1 by 4. Similarly, x to the L mth root of x to the power L minus m can be written as x to the power L minus m upon Lm into x to the power m minus n upon mn into x to the power n minus L upon nL. Now again the bases are same but the powers are different. It means there will be only one base and powers will be added. So I am solving this separately first. Means if you solve L minus m upon mn, this can be written as L upon mn minus L minus m upon Lm can be written as L upon Lm minus m upon Lm. When you solve this, L and L will cancel, you will get 1 upon m minus m and n cancel, you will get 1 upon L. It means in place of this, we can write 1 upon n, m minus 1 upon L. So x to the power 1 upon m minus 1 upon L into, similarly, this m and n will cancel, you will get 1 upon n minus 1 upon m, and similarly in this n and n will cancel, 1 upon L minus 1 upon n. Now bases are equal, we will add the bases. It will be 1 upon m minus 1 upon L plus 1 upon n minus 1 upon m plus 1 upon L minus 1 upon n. Now 1 upon m positive, 1 upon m negative, cancelled, 1 upon L positive, 1 upon L negative, cancelled, 1 upon n positive, 1 upon n negative, cancelled. You got x to the power 0, something to the power 0 is 1. That is the final value. This was question number 19, first part, and this is very important. So I expect everybody to please practice this. This is very important. Now we move on to, I am leaving the second part, we are moving on to third part. Now this 19th question, third part is x to the power a upon x to the power minus b to the power a square minus ab plus b square into x to the power b upon x to the power minus c to the power b square minus bc plus c square into x to the power c upon x to the power minus a to the power c square minus ac plus a square. What are we going to do first? This negative power will go to the numerator, it will become positive. So this can be written as x to the power a plus b and whole power a square minus ab plus b square into x to the power b plus c to the power b square minus bc plus c square into x to the power c plus a to the power c square minus ac plus a square. Now what we do, we know that if there is a power of power, the powers get multiplied. So first we will multiply these two and check what is the value. Means a square minus ab plus b square multiplied by a plus b. When you multiply, b into b square is b cube and b, this will become a b square b minus ab square, and this will become a square b. Then again we multiply a into b square. A into b square is plus ab square minus a square b and plus a cube. When you solve them, this minus plus cancel, what is left? A cube plus b cube. So after multiplying these two, we are getting a cube plus b cube. So we can write x to the power a cube plus b cube into x. Again, when you multiply them, you will get b cube plus c cube into x to the power. If you multiply this and this, you will get c cube plus a cube. Now bases are same and powers are different, so base will remain same, but the powers will get added. Means a cube plus b cube plus b cube plus c cube plus c cube plus a cube. Everywhere you can see a cube and a cube will make 2a cube. b cube and b cube will make 2b cube, c cube and c cube will make 3c cube. So this can be written as 2a cube plus 2b cube plus 2c cube. We can take 2 common from the power. So what is the value? 2 times of a cube plus b cube plus c cube. That is the final value. Now we move on to question number 20. Now question number 20, I have taken the second part. I have left the first part. First part you will do on your own in your practice notebook. Let's see what is there. Now a to the power m minus, this question is 1 upon whole upon 1 plus a to the power m minus n plus 1 whole upon 1 plus a to the power n minus n. First of all, we need to concentrate on these two things. If it is written a to the power m minus n, it means it is a to the power m into a to the power minus n, because we know that powers get added and when the bases are same. So this can be broken like this, and if it is minus n, we can write it as a to the power m upon a to the power n. So I am writing this directly as this. So 1 upon 1 plus can be written as a to the power m upon a to the power n plus 1 upon 1 plus a to the power n upon a to the power n. Now if you solve the denominator, this will become as the LCM. This can be written as, I am writing it here, can be written as 1 upon a to the power n plus a to the power m whole upon a to the power n, and plus 1 upon a to the power m plus a to the power n upon a to the power m. Now denominator's denominator will become to the numerator. So it can be written as a to the power n upon a to the power n plus a to the power m plus, this will again go to the numerator. It will become a to the power m upon a to the power m plus a to the power n. How you can write this? I am writing this portion also this side. It means 1 divided by a to the power m plus a to the power n upon a to the power m. Now you know when you solve the division sign, it converts to the multiplication sign and the next fraction becomes reverse. So this can be written as 1 into a to the power m upon a to the power m plus a to the power n. So something into 1 is the same thing. So a to the power m upon a to the power m plus a to the power n. So that is what we have got over here. Now in both the things you can see that the denominator is same. So we can take the LCM as a to the power m plus a to the power n. This divides this, it becomes 1. 1 into a to the power n is n plus this divides 1 into a to the power m is n. You can see both numerator and denominator are same. So this whole thing will cancel this whole thing and final answer is 1. That is the final answer. Now there are few questions of proving. I will take question number 21, first part for proving. Now question number 21, from this question proving starts. Now in proving, how do we proceed? We either proceed, this is known as left hand side, because this is to your left, so this is known as left hand side, and since this is to your right, this is known as right hand side. So what we do, either we start from right hand side and we prove that when we solve up to the answer is equal to left hand side, or we solve left hand side and prove equal to the right hand side. So in this I will be starting with left hand side. So first we need to write LHS. LHS means left hand side. Now what is the question? A plus b to the power minus 1, whole power minus 1, can be written as 1 upon a plus b to the power 1, either you write or you don't write. Since the power was in negative, I brought this whole thing to the denominator and the power turned to be positive. In the second one, that is multiplication, it is a to the power minus 1 can be written as 1 upon a plus b to the power minus 1 can be written as 1 upon b. Now when you solve this, you will take the LCM as AB. A divides AB, you get B. B to 1 is B and plus here you will get A. And here it was 1 upon A plus B. You know that A plus B and B plus A are same. So this and this will cancel. This, what is left? 1 into 1 is 1 upon AB, and that is your right hand side. So it is proved. Now let's take other question. Okay. Now in the second part it is prove that x plus y plus z whole upon x to the power minus 1 into y to the power minus 1 plus y to the power minus 1 into z to the power minus 1 plus z to the power minus 1 into x to the power minus 1 is equal to expanded. We will proceed from left hand side. So first I am writing LHS. Now what we do, it is x plus y plus z upon x to the power minus 1 can be written as 1 upon x into y to the power minus 1 1 upon y plus similarly 1 upon y into 1 upon z plus 1 upon z into 1 upon x. Now I can take, this can be written as 1 upon xy, 1 upon yz, 1 upon zx. I am solving it this side, this portion. 1 upon xy plus 1 upon yz plus 1 upon zx. This can be written as 1 upon xy, so 1 upon xy plus 1 upon yz plus 1 upon yz plus 1 upon zx plus 1 upon zx. Here LCM will be x, y, z. xy cancelled xy, z is left, z into 1 is z. Similarly, yz cancelled, it is x. Similarly, zx cancelled, y is left. It means this total portion can be written as, this is x plus y plus z upon, this total portion can be written as x plus y plus z upon xyz. Because after solving this we are getting x plus y plus z. So I am writing x plus y plus z upon xyz. You know that denominator of the denominator goes to the numerator. In the previous question we have written. So x into y into z into x plus y plus z upon x plus y plus z. What happened? This, so it is multiplied 2x plus y plus z, that is why it is written xyz into x plus y plus z, and since now denominator is x plus y plus z, so denominator is left. Now this and this will cancel. What is left? Only x, y, z is left. That is what was required to prove. So that is equal to right hand side or RHS. Now we have finished 21 questions. Now from 22 onwards, since they are all to be explained, I think, so I will be taking another class to explain you all these things. For now you will practice all these questions. All these questions are supposed to be in your fair notebook, whereas whichever questions we have left, that you will do in your practice register. And in case any doubt, you can send me the question on this number, or you can comment in your comment box. Thank you. Have a nice day. Stay blessed.